Am I loud?
Hold on. You're loud, thank you. Okay, what I need is, of course,
Oh my God, it's Rhea.
That's so crazy. Hello, Ray.
Oh my God.
No.
Hope so.
I could have these in the bushes with the ants in the bushes.
It's a closely right move.
You're just using it wrong.
How the fuck am I supposed to use it?
Just don't break it.
Then break it.
It's pretty fucking simple. Look at my phone.
that's what I need. Bring the chalk up, all of it, bring all the chalk up, all the chalk. Quinn and whoever it is, Laura, bring up the chalk.
Yeah.
Because I have none up
Good
here.
morning, JFK. We have two quick announcements for you today. Stop by the Feminist
Super,
Initiative
thank
spring
you.
sale on
Hallelujah.
Thursday, January 13th, and Friday,
Hallelujah.
January
Thank
14th.
you. Who's that?
We will be selling clothing and stickers during 6th hour in the main building. All proceeds will go to the Sarita Sephorian House for them. For more information, stop by our meeting on Monday during the 20-minute break or email the feminist initiative at jfksberlin.org. And secondly, to student council members, a reminder that this month's student council meeting is this Thursday during 4th period. That's it for today, JFK. Have a great day.
They always make the student council meetings during time.
Which I hate. And they've done something else too. Either next week or the following week, we have, it's on the Tuesday and there's 5th period and then they're cutting it off early, I guess, but I'm going to try and see if we can all meet 6th period instead of 7th period before you head home. But more when I get that specific date from, it's in either next Tuesday or in 2 weeks. You're in school at all?
Yeah, the only way we have school is if you have like an online class.
Then we'll have an online class, but I mean, I can't just throw away another day with you. So they told us in an email that you were here through 5th period. They told you that you're not here at all that day.
Well, so
Is it in 2 weeks or 1 week?
So the last week before.
Yeah, that I know about. I'm not, there's nothing I can do about that. I'm talking about next Tuesday.
there's nothing next Tuesday.
There's nothing next Tuesday, then even if you hear something, we're gonna have class, okay? So just be here, and if they change something, then we do it online, but I'd rather you be here. So I'm a little irritated because they suddenly put some sort of 7th grade meeting. I don't even have a 7th grade, but I don't want them to cancel school for that. Because, how should I put this? You and I have a race. And the race is to get through this flipping book by April 4th. And it's a lot. So, okay, questions, comments, Noah?
Well, I know I usually have class 6th period on Tuesdays, so if they're putting us on at the 5th period, I would have classes. Are they putting us on at the 6th period?
I don't know. It was unclear to me. That's why I'm asking all of you. Okay, so if it's a normal day next week, Noah, hallelujah. And we'll just have a normal Tuesday. I hope that is indeed the case. but I want you some way or other, even if it's online.
I think the one day that might be special next week is Wednesday.
But that's not a factor for us.
Yeah.
That's not a factor for us. Okay, so due Thursday is your chapter 1. So I hope you got some questions on it. I'm ready to hear Aaron.
So on page 12, number 4A.
Am I hearing right?
Yeah, A and B.
I'm going to close this rear window and I'll reopen it in a few minutes. Once the Lord willing.
No, I was just saying that with no reason.
Whew.
I'm not saying anything.
Okay.
Reaction, this is the-
I'll try to remember to lift them in a few minutes. But let's have a little piece while I look at number 4. Okay, page 12. So flip to page 12, everybody. Let's have a look at 4. And it's a good one. It's an experiment. So let's see what's going on. It's collecting gas as some strontium metal reacts with hydrochloric acid. Okay, that's cool. And then calculate the average rate of reaction over the first 50 seconds. Okay, let's do it. So 50 seconds. So rate's going to be HCl consumed per second. That's the label we want. Okay, so to get it, we'll certainly divide by seconds. Even if you haven't done this yet, Rhea, 50 seconds. And let's see if we can figure out what's going on with the HCl consumed. Okay, well, we don't have HCl consumed, but gang, we have at 50 seconds, 72 milliliters of H2 gas. So what are we going to have to do with the milliliters of H2 gas? Change it, Noah B, to?
Well, HCl. Well, we have to like convert it so that we get the HCl.
Yeah, eventually we're going to have to get HCl. So let's,
Using the reaction.
using the reaction. Okay, so here we go. We're going to take our 72,
You have to convert that to liters, though, so-
you got it, milliliters of H2 gas. And eventually we want to get that to HCl consumed. Is it moles or what is it? They want it in moles of HCl consumed. Okay, so let's do a plan. So we got milliliters of H2. No, it says we got to change that to liters of H2. We can do that and change the liters to, hint, it's STP, so I change it, Rhea, to. You got it. We can do it in one step. And finally, from moles of H2 to moles of
HCl.
HCl. Let's do it. Okay, let's do this mentally. How about back to Aaron? 72 milliliters would be how many liters? Thank you very much. Okay, now we got then 2 arrows, so 2 conversion factors. So anytime I do a plan, and I do it like in this sort of problem, I have to think my way through it. And then let's just do some labels. So we got liters, we got moles, and we've got moles H2 and moles HCl. And even without looking at the reaction, Quinn, I need what ratio here?
2 to 1 to moles hydrochloric acid to 1 mole of hydrogen.
You got it. Okay, because there's 2 in there. So, but that you can get that from the reaction if you like as well. It's the same relation. Okay, what was the deal with STP? So what do I put in for this little spiky spot? Rena?
1 mole over 22.4.
Well done. Soupy. Okay, so there you go. All of that will be our answer, and that's all going to go here, and then we're going to divide it by 50 seconds. You can go ahead and do that if you want, folks. and get the rate for part A. And while you're doing that, I'll look at part B. Okay, what'd somebody get for A? For the rate in per second, moles HCl per second? And what'd you get?
1.29 moles per second.
Sounds great. Moles per second.
Just,
Although it seems like a lot.
Yeah, I got something.
I'd say it seems like a lot, Aaron.
I got 1.29 times 10 to the negative 4.
Yeah.
Yeah, I think it's gotta be something small, because that's not a lot of H2. Okay, times 10 to the negative 4?
Yeah.
That sounds way better.
does someone have the intermediate value, the one that you do over 50 seconds?
0.0064285.
Good, okay. Then part B, all you need to do this, all of you, is a plan. So here we go. Calculate the mass of strontium consumed in the 50-second period. Well, you know what? You already got the moles of HCl. Why don't we just change the moles of HCl to moles of the chemical they're asking about, moles of strontium, with the balanced equation and then the grams of strontium. And I think I'll leave that for you to do. I'll leave that for you. Okay. Aaron, does that help get you there?
Yeah.
Okay. Questions from you or anyone else on other ones here, chapter 1, that we'd like to look at together? I'll make sure my folks at home can see that. Hint for page 12 for A and B. You want to look at 5?
5A, no, just A, because I thought that it would be delta, like concentration from 0 to 80, which would be 0.042 of the 80 seconds. But then the book had a different answer than I did, so.
Well, the concentration, Aaron, you're going to get, did you already get those from the calibration curve back here?
Yeah.
You did, okay.
So at 80, it's 0.042. So then I thought that from 0 to 80, we would just take that value over the 80 seconds.
Okay, you're moving a little fast for me. I got to go back and look at this data. We're talking about page 14, 5A, is that right? Okay. So let's make sure the folks at home know what we're looking at too. Okay, so, and they want it at 80 seconds. Okay, so 80 seconds, we got an absorbance of 1. So if I go on the absorbance graph on page 13, I got over a 1, and I get a concentration of like 0.04 something. Is that what you got too?
Yeah, I got 0.042.
That sounds great. So I have absorbance of 1 at 0. Is it 42 or 042?
Oh,
Thank you. And is it molarity probably? Yeah. Moles per liter. And this is the copper nitrate, copper 2 nitrate.
Oh, that this was the problem. Asking for the molarity of patient.
Yeah. So you'll have to use an equation. Oh, they give you the equation. Yes, you'll have to do what, 3 to 8, it looks like, as a mole relationship, Aaron? Yep. And a copper sample was reacted with 250 grams of nitric acid. In units of molarity HNO3. So it's going to have to be probably that, I'm guessing, in times what? A molar ratio of 8 moles. No, other way around, wouldn't it? 3 moles of, it's a 3 to 8 ratio. 3 moles of copper nitrate and 8 moles of HNO3. If you want to do that and see if you get then, Aaron, the right thing when you divide all of that by, where are they? 80 seconds, is that what they want? Then divide by 80 seconds. And I hope, Aaron, that gets you there. It should, I think. It should. Rhea?
I have a question on page 80.
80.
Yeah, 2C. It was like
Good.
a quick clarification question.
Good. Let me get there.
Yeah.
Okay, everybody turn to that, page 80. And it's 2C. And I'm going to put it on the board. It says find the molecularity. What the heck is that? I got to remember that. Of each of the following reactions. So 2NO. Sounds like a joke. What a molecularity type joke. Plus Cl2. Makes 2 NOCl. Good. Now, I ran through this about a month ago, so I don't remember what molecularity was. Let me look back and see what she says.
Like the paragraph above the quick check.
Yeah, exactly. So the molecularity of each elementary process is defined as the number of reactant species that must collide. Okay, why give it such a fancy name? To produce the reaction indicated by that step. So what's our molecularity for C? Well, it's looking like how many there? How many molecules everybody are colliding? I got one person, but everybody else is kind of dreamy. So focus in. Whoop! How many molecules are colliding? Gwen?
3.
3. I think it's looking like 3. Do they have something else though?
No, they had that. I was just wondering what they meant by species.
So, species in chemistry. Don't you love that? It's like learning a new language. It's a chemical reactant.
Okay. So,
Does it mean?
No, it's just a chemical. It could be a reactant or product.
okay,
So-
because I wasn't sure if the 2 NO like counted as 1 or 2.
I don't know if it's because we're like lonely because we don't have actual animals in chemistry, but we call them species. So in this, NO is a species and NOCl is another species that is a product.
So hold up. Two different types of chemical collide, but 3 molecules. Which one's the answer?
3 molecules.
Okay, so there are 3 species combined.
No. There are 2 species, but one of them has,
Did they ask for?
whoops, 2. I put a 2 there.
Yeah,
so-
did they ask for the number of species or molecules colliding?
Molecules colliding.
Okay.
So that's what the molecularity is according to your book. I've never heard that term on the AP, by the way. Don't worry too much about it. But you do need to know to figure out how many molecules are colliding. So if you can count to 3, you're all set. Rael?
I was just wondering because it says that a reaction involving 3 species is called termolecular.
Oh, boy. I thought it was 3 molecules. Let's look and see what she says. Okay. A reaction involving one molecule is unimolecular. A reaction involving the collision of two species, now she's getting sloppy. Do you want two molecules or two species? And a reaction involving three species, okay, I disagree with her terminology. I would say it's two molecules and three molecules. Species I've always used in chemistry is to mean a reactant, a specific species of chemical.
Why is she like changing the different? First she says
Molecule, and then she
molecule,
says,
species, and then species.
because it's a typo. And I suppose when you write two whole books, you do make some mistakes. And thank goodness she makes some mistakes because I make a lot more than she does, that's for sure. Okay, thanks for asking about that, Ray. I think that's got to be the clarification. But the most I think you guys need to know is just exactly that. How many molecules are colliding? Good. Other questions or clarifications from any of you on anything from chapter 1? Okay. No? All right, that's fine. Then we're going to spend our hour looking at chapter 3 ideas. So I've already introduced chapter 2. I won't get too far ahead of you, but I'll tell you why I'm doing this. I always like to be one chapter ahead of you all anyway. I'm doing 2 chapters because we're coming up on winter break. And if you, as I'm guessing a lot of you will, want to work on some chem during winter break, you will at least have the guidance through your notes of stuff on chapter 2 and 3. You know what I'm saying? So,
When are they due? Chapter 2 is due before break, right?
yeah, chapter 2 is due before break. I think like right before break. And by the time we get there, we'll have talked about chapter 3 stuff as well. So we'll put a due date on chapter 3. The approximate sheet that I worked out on the board with you, the timeline is what I'll use. I have that in my office. In fact, I might even have that here.
Chapter 3 is due the Tuesday we get back.
Yeah, so chapter 3 is around February 8th. So when we return.
And chapter 2 says it's November 24th. so we don't
Yeah,
have school.
chapter 2 is due the 24th, but we don't have school then, so I won't be able to grade it until you're back anyway from winter break.
Like, don't see the Thursday of that one.
Yeah, I don't know if we have school on that Thursday or not.
We
Oh.
do.
Do we?
We don't have school Monday, Tuesday, Wednesday, right?
Right. Thursday, if it's a regular day, that'd be awesome. And as you could guess, if some of you are done, I can grade your books. I probably won't have a chance to grade every single book that day anyway, Gazunite. So don't panic if you're not caught up. On the other hand, I got to crack the whip with you a little and say, don't get too far behind because the snowball is only going to get bigger. So you really got to put some time into chem here the next couple of months. I can't stress that enough. And again, when I'm here offering you time to answer questions, please do use it. Mark things, get them nailed, keep working on. Probably you should think about doing about an hour of chem a day. So if you can't do that, then you're stuck on a weekend doing 5 or 6 hours, and that's too much. So try and do some every day. I'm not a big agreeer. Oh, I'm going to do chapter 3. Well, then you're going to be there all Saturday and Sunday doing it. My class I had 2 years ago, which was my first class with Sherry's book, said per section, it took them between like an hour and a half per section. Some were harder, some were easier. I don't know what you're finding, but some of them were pretty talented folks. Questions, comments? Noah? D?
As we get closer to the actual AP exam,
Yeah.
do you suggest that we start familiarizing ourselves more and more with the type of questions, like just like doing a few problems a day, FRQs, or what's the best way to prepare?
That would be great. So it depends on you and your schedule, but I opened up and freed, I think, a lot of those review things that are online through the AP. So you can use those as you cover those topics. I'll try and assign another quiz or two here in the next few weeks. so that you're kind of everybody forced to do one with some multiple choices and one FRQ probably. And then in class, once I feel like we're caught up and have some time in class, we're going to work some more of those AP College Board problems together as well. Multiple choice and maybe an FRQ or two. You know what I mean? So I want to try and do more of that as we go along. As you're guessing, I don't have a lot of labs to do. We'll do some more demos, especially with stuff in this chapter. Any labs I can squeeze in, I will. But it's such a race this year to get this stuff done. We won't have necessarily a lot of lab time before the AP. But we got to do 1 or 2 with acids anyway. We'll have some labs. I'm going to guess we're going to have between 3 and 5 labs between now and the AP. Anyway.
Have you graded the quiz that we took before the break on AP class?
I have not. I've been overwhelmed with my grading of 8, 9, and 10 tests. So I will do that, but I've not done it yet. So my apologies. Okay. Anything else from any of you on our long-term business? Then we're going to crank through some ideas of chapter 3. We more or less finished 3.1 yesterday. I want to review it a little bit and ask you a question or something, maybe with it. Yeah, let's ask you some that, let's use the same darn thing. I love it. Is it really? That is great. Okay, let's use this. So, erase teacher and no, where is it? There it is. Okay, let's take the same reaction. So we're going to review 3.1 section, and it's the first step in equilibrium. And we're going to use this sucker right up here. So 2NO gas plus a CO2 gas forms 2NOCl gas. And I'm going to do a couple with you that I didn't assign. So I'll just ask them as questions. Two grams of, let's do this one. Two grams of NO consumed per second equal grams of NO produced per second. Now I got to give you the conditions. When equilibrium has been established. Okay, so now let's make it double arrows just to emphasize that idea of equilibrium. And Tom, the equilibrium thing means what? The reaction can go either one way or the other, forward or backward. We call it something with R. Reverse. So forward or reverse. Okay, so and recall equilibrium before we answer this question. What is it about those two rates once we've hit equilibrium? What is the case? Equilibrium means the forward and reverse rates, Lena?
That they equal, so they don't increase or decrease anymore.
You got it. So the rates are the same. The chemicals don't increase or decrease anymore. Good. Now let's look at the question I wrote. So do the grams of NO consumed per second equal the grams of NO produced per second when equilibrium has been established? You got a 50-50 shot, right? Okay. What do you think, Aaron?
I want to say yes.
I want to say you're correct. Why, Aaron?
Well, because you have 2 NO for every 2 NOCL. So, I mean, since you're using 2 in both, if you have the same rate going back and forth, then it can be the same consumed as produced.
Yeah, good. So it says 2 of these are used to do whatever, or if I come back the other way, the reverse reaction, and I make 2. So I'm either consuming 2 or making 2. So I think we got to say that the answer is yes. Right.
What would be an example where the answer would be no?
Well, how about this question? To the same question, 2 grams of NO consumed per second equal the grams of NOCl produced per second when equilibrium's been established. And now, Ray, you can answer your own question. So now we're going to compare the grams of NO consumed at equilibrium. Is it equal to the grams of NOCl produced at equilibrium? And you're already shaking your head, and you're correct. It's not true because, of course, on top of everything else, what have I changed, folks? Especially if I say grams. What's the problem here? Gwen?
The molar mass has been increased by chlorine.
Yeah, and so they're no longer the same number of Thank you, Noah. You got a question too.
No, man, you good.
Go ahead. Yeah. Okay, so if I change the molar mass, all bets are off with grams.
What are the other things that make it like untrue?
That's the main thing that makes it untrue. The fact that suddenly I've got, okay, what if I did this? And Ray, this might be your question. What if I change this? Let's see if it's still no. I'm going to raise our answer. So let me read it off. So
Let's say nitrogen oxide instead of no.
no, it said no. But thank you.
Which one did it say though?
It said no, NO.
Which one is that one?
Is this like who's on first?
Yeah.
It is. I appreciate your humor. Okay, so we
Can you
go.
tell me the
So
formula
the
for
moles of
nitrogen
NO,
oxide? No.
if they're consumed, okay, per second, is that going to be equal to the moles of NOCl produced per second? Right.
Yes.
Yeah. Yeah. Now, because it's an equal number of moles on each side, 2 to 2, that will actually be true. And I can even like change the wording and say, will it equal the number of ones produced or even consumed? Yeah, it should be all equal if it's equal rates going back and forth with both chemicals because it's a 2 to 2 ratio. And our 2 rates are equal, forward and reverse. But that wasn't your question after all. Right?
No, but if you have, like for A, since we have like the same NO for consuming and producing, there's always going to be, the answer would always be yes, right?
Yes.
Okay.
Agreed. Thank you for your good thinking, everybody. Oh, let's go on to this beautiful thing. Let's go on to this beautiful thing called Le Chatelet's principle, which makes a lot of sense and you'll like it. And it's fun to say because it makes you sound sophisticated. So we're on section 3.2. Le Chatelet's principle will be about the main way you're going to argue stuff on the AP for questions that involve dumping things in reactions or removing things from reactions. Let's first see what the heck it is. Okay. Le Chatelet, in brilliant French, said that a system at equilibrium that is stressed. What the heck does that mean, Mr. Weiss? Let's see. It's not like your stress. Well, your stress would be chemically related also. Will partially shift I would say so as to, how does she say it? To somewhat alleviate the stress and restore equilibrium. Okay, so what the heck we're talking about with the stress? Okay, let's give you a reaction maybe on the side to help you come up with an answer to that. Let's just do the one that she does here. So 2 SO2s plus an O2. Three, does that add up right? I hope so. Yeah, these are all gases. Okay, a stress is more or less dinking around with the system. Okay, so I got SO2s, I got O2s, and I got SO3s. And they're now in equilibrium. Oh, the forward and reverse rates are equal. Life is beautiful. How can I mess with this? I can mess with somebody's mind. What could I do? Give me one thing I could do to put some stress on this, to change the situation. Put it on fire. Well, no, because that's a different reaction. So I can't
heat
do
it
that.
up, is what I meant.
Okay, heat it. Changing the temperature. So heating, I could cool it as well. Good, that's a stress point. Another stress. What else could I change here? Yeah,
You could change like the density or like the pressure.
the pressure. There you go. Especially with this one here, because I got what phases? Gases. Beautiful. So a stress is adding heat or cooling, and I could either increase or decrease the pressure. We'll just say change pressure. Good. One last thing I can do, Nobi.
Maybe adding.
You got it. So adding. Or it turns out I could take it away too. So add or, yeah, I'll just say take away. Some of one of the chemicals. Cool. Can my folks see that at home? I hope so. Ah, I hate it when it disappears. Okay, let's see if I can read that. Damn this thing. Stay. Technology. Okay, so folks at home, I think, can see that now. The good thing is they can always stop the film. You poor people have to see it live. Okay. All right, so just kidding, just kidding. Let's do some stresses with this one. Okay, so I'm going to rewrite it down here just so I got it to point at. Okay, so gas. Okay, let's start with a chemical. Okay. A, add more SO2. Okay, so now, who did I do that? Did I do that in this class, the ping pong balls, or was that another class? I did it with you guys. Oh, this is right. So, if I add more of a chemical, and only one of them, so I'm gonna dump in more of this. So if this is my ping pong balls, I am just dumping them in here. I did it with Leah, that's right. So what's the reaction gonna probably do to sort of counteract that at least a bit? Which way will the reaction move, so to speak? If I dump in more, how will it reduce that stress? By doing what? Right now, the rates are equal. We'll have to do what? No, D?
By consuming more oxygen
Yeah, and going in which direction, forward or reverse?
forward.
So temporarily, this stress is going to make the reaction run more forward and produce more products, right? So that's what this stress does, but not forever. It will do this for a while and then do this. And we're going to see from Cheryl how to show that in a number of different ways, and I'll help you with that. Okay, so
Is her name Cheryl or Cherise? Yes.
well, she goes by
Sherry is going for Cheryl.
yeah, she goes by Sherry as the book name. I had her introduced to me as Cheryl, so that's why I'm afraid I go back and forth.
Is that a Canadian name?
Not that I know of. A question I'd never thought of, Noah. Okay, so So that's how I want you to think. First about arrows. So this stress causes more of a forward reaction and less of a reverse reaction. Do a particle model for me. So why am I getting more of a forward reaction? Because, talk to me about particles.
There are more sulfur dioxides for the oxygen molecules to react with, thus speeding up the reaction with the, yeah.
Exactly. So I have more collisions. Remember, reactions are about collisions. So Quinn is right, more particles. So I've increased the number of collisions. And so I do make it happen faster. That's why it works, right? That's why it works that way. Eventually you get this though again. And let's see if Cheryl does it in this section. Yep, she does, so I better do it. Okay, she's got kind of a wacky way of writing this, and maybe she took it from other chem teachers. I'd never seen it before. It took me a while to figure it out. So we're going to look at one on page 157. So she uses E1S, no, EIS and E final. Okay, so does she use a different reaction? She uses one, we're going to do it a demo probably on Thursday. Everybody just look at that for a second. For a second. You got a book you can look at? So page 157, down at the bottom of that thing, EI is probably standing for what? EI, no B?
Energy initial.
Not energy, but
Yeah.
Equilibrium. So you got an initial equilibrium. And notice the arrows are the same length. Same length. That's just going to stand for the what? You can look back on these two if you want. That's gonna stand for the what there?
Stress.
The stress. And that stress, in the case of one they just did, made the forward reaction do what?
The arrow's longer, which means that the rate was higher for the forward rather than the reverse.
There you go. Okay, then the bottom one, EF is going to stand for the equilibrium and final. And what do you notice about the arrows are the same length, but compared to the initial, what do you see? What do you see there?
They're longer than an initial.
They're longer than the initial. So I made, even though it's at equilibrium, the forward and reverse rates are both more than they were before. So that's why this Le Chatelet's principle, check it out. I alleviate the stress somewhat. In other words, it doesn't go exactly back the way it was. In this case, it's shifted on page 157 so that it's a little more forward and reverse rate. We'll do something like that when we come back. You can leave stuff in here if you want. I'll lock up the room. And I'm going to end this and restart one here in a little bit.